Next is a fact that for any conductor, the electric field is always perpendicular to the conductor. Electric field lines are perpendicular to the conductor. Actually, these are some theoretical sections in the NCERT book which may be asked as explanatory question in the exam. That's why I'm pointing it out separately. What is that meaning? So for a conductor, suppose this is the surface of a conductor. For the surface of the conductor, electric field lines are perpendicular. That is a statement. So, you know, conductors have got so many free electrons, right? Conductors have got so many free electrons. Statement is the electric field are perpendicular to the conductor. That is the statement. I will say the contrary. If it is not, but if the electric field were not perpendicular, let us think like that. If the electric field were not perpendicular, then this electric field will have two components. One is parallel to the surface and other is perpendicular to the surface. So if there exists a parallel component of electric field, the electrons in the conductor should experience a force F equal to EE, ready, opposite to the direction of this parallel electric field. Means the electrons here, all the electrons here should experience a force in this direction, F equal to EE. Okay, the electrons in the conductor should experience a force opposite to the direction of the electric field. Then the electron should move, because inside the conductor the charge can move. What it means, if electron moves, there will be a current. If electron moves, there will be a current. Means if you keep a charged conductor, there should be automatic current flowing over the surface. If the electric field was not perpendicular, or if the electric field is inclined. If the electric field is inclined, there should be two components. One is parallel to the surface and other is perpendicular to the surface. In case of parallel electric field, the electron should experience a force opposite to the direction of electric field, and those electrons should move in the conductor. And that should constitute a surface current in the conductor, which is not happening. So it is not possible that the electric field can have any direction. So electric field can only be perpendicular. That's it. The electric field is only perpendicular to the conductor. So that there is no component acting along the surface. So there is no possibility for surface current to exist on a charged conductor. Next point is, if you place a conductor in a uniform electric field, I will repeat, if you place a conductor in a uniform electric field, the electric field inside the conductor is zero. If you place a conductor in a uniform electric field, suppose this is a conducting material. You know, conductor is a conductor. Why? Why conductor is a conductor? Because of the presence of so many free electrons. Free electrons means valence electrons, which are less bounded with the nucleus. So those electrons are free to move. They do have greater degrees of freedom to move away from the influence of the nucleus. So this is a conductor. So it have got so many free electrons with it. And we are placing it in an external electric field. Means what? There is an electric field existing everywhere externally, and let that field be E0. Right? So E0 everywhere. Everywhere. Suppose everywhere. I can write it like there is an electric field E0 existing everywhere. Okay, within the conductor there exists electric field E0 everywhere. Why? Because this is placed in a space where there exists an electric field. Now this have got so many free electrons. And what will happen to that free electrons? The electrons will move opposite to the direction of electric field. Listen to it. Means what? This is the direction of electric field which is given externally, and the electrons will start to move opposite to the direction of the electric field. So if electron is moving opposite direction, naturally there will be a polarity arising in the other direction, other side, positive charge, because deficiency of it will produce positive charge. Deficiency of electrons, yeah. So this side will be negative, this side will be positive, this side will be negative, this side will be positive. So numerous value of electrons are there. Large values of electrons are there. So many electrons will start to migrate opposite to the direction of the electric field. So naturally there happens a potential difference. One side will be high potential and other side will be with low potential, or one side will be with positive potential and other side will be with negative potential. So there happens a new field, right? Yeah, that's it. There happens a new field from positive to negative. See, E0 is the external electric field applied, and E induced electric field is existing in that material. And that E0 will be equal to E induced. So that net electric field will be equal to vector E0 plus E induced. So sum will be equal to what? 0. This is what is happening in a conductor. When we take a conductor in a uniform electric field, when we take a conductor in a uniform electric field, the net electric field inside it will be 0. The net electric field inside it will be 0. So this is because it have got that much number of free electrons. It will arrange itself. The free electrons will be arranged itself in an orientation such that the induced electric field developed inside the material is equal to the externally applied electric field, so that the net electric field inside it is 0. Now another one, suppose you have a spherical shell, something like this. Okay, spherical conductor, solid conductor, just like a shot put ball. Spherical conductor, metallic conductor you have, and you place charge to it, or you give charge within it. And you give charge within it, right? If you give charge within it, those charges will repel each other, because you give additional point, you give positive charge to it. The positive charge will start to repel, and this medium inside is conductor, so the charges can move away. Okay, so the charges will repel each other and they will move away, and they will move away. Suppose we are giving negative charge, the charges will move away until all the charges are coming over the surface, so that they are separated maximum. So for a conductor, if you give charge, that charge will only be at the surface. See, this we applied in Gauss's theorem to find the electric field at any interior point, where we draw the Gauss's theorem inside, and we argued that there is no charge residing inside. This is why there is no charge residing inside. Because of the mutual repulsion, the charges will move as much away from each other, that much it will move away, so that the net charge within it will be 0. This is what is happening with the charge. Now, in the same way that I gave charge to the conductors, suppose I am taking a dielectric. What do you mean by dielectric? Dielectric means something, an insulator, like wood, wax, something like that. Paper, cardboard, everything are dielectrics. They are insulators, that's all. Where the number of free electrons are not that much good. It's not that excess. Suppose you apply an electric field E0, right? There will be some possibility for drifting of electrons, but the number of free electrons are very less, very less, so that the electrons shifted will be less in number. Definitely there will be an induced electric field. There will be an induced electric field. It will be wrong if I say there is no electric field induced. There will be an induced electric field. But that induced electric field is less than the applied electric field, so that the net electric field will be E0, vector E0 plus induced. Since they are in the opposite direction, I have to say the modulus will be E0 minus E induced. And that is not equal to 0. So there will be an electric field developed within the material, or dielectric. There will be a net electric field developed within the material in case of a dielectric or an insulator, while in case of a conductor, the electric field inside will be 0. Okay.